So let's start the comparison test. Okay, so the two tests I'm going to show you now are probably the more tricky ones. Okay, but okay, let's take our time and understand it. Okay, so the first comparison test, what it is as follows: if an is smaller than or equal to bn for all n, okay, and the series bn converges, then the series an converges. Okay. That's the first statement, and the second statement of the comparison test is that if an is greater than or equal to bn for all n, and the series bn diverges, then the series bn diverges also. That's the whole thing. This is the comparison test. Of course, we're talking just about positive positive terms, okay? We didn't start talking about negative terms yet. Okay, so let's understand what this means. So you have a series an, okay? That's going to be given to you, and you're going to be asked, does this series converge or diverge? Okay, so usually it's going to be a complicated term. So if you could find another series, so you have to come up with bn, you have to come up with this series that you know that it converges, and you know that it's greater, every term is greater than an. If you could come up with such a series, then an, you just prove that it converges as well. Okay, if I want to make an illustration for this, and then we'll do examples, of course.
Okay. Sir?
Yes?
I think you made a mistake on the second line at the end. Is it the series?
Oh, yeah. Sorry, that's an, right? That's what you mean?
Yeah.
Yeah, sorry, thanks. You're right. Thank you. Good. So I see you understand. So if I want to make an illustration of this, okay, so I have a series an, a term an, and a term, okay, and it's like if so the bn is always bigger than an, okay, that's the first case. So if bn as n goes to infinity, eventually it stabilizes, okay, so eventually it's going to stabilize somewhere because it converges the series. Well, since an is less than bn, well, for sure, bn will stabilize as well. That's what it means. If bn converges, an, which is following bn, could never exceed bn, so it cannot diverge. It has to stop somewhere, so it must converge as well. That's the logic. Okay, and for the second, okay, did you understand this logic? We'll do an example with actual series. You will see, you'll understand it better. Okay, I'm just saying a bit more in the theory. 2 seconds. Second case, okay, imagine now that bn is less than an, always, okay? bn is smaller, so you just found a smaller series, smaller than bn, smaller than an, I mean, and bn goes to infinity. It just goes on forever, it diverges. Well, since an is bigger than bn, right, well, it has no choice. It has to go to infinity as well. That's the idea. Okay? So you will have to find, if you suspect, and I'm going to show you how to get an intuition whether the series converges or diverges. If you suspect that AN diverges, but you cannot prove it with the tests, either the divergence test or integral test, or it's not a P series, or it's not a harmonic series, right? Or geometric, so you can't identify any of the series that we showed before. What you could do is you could find a series which you know that diverges, but that is smaller than AN. If you could do that, you would have just to prove that BN diverges, which is probably easier. And then since this is, and you have to prove that AN is bigger than this, that proves that AN diverges as well. Let's do a few examples, okay? So example 1. So let's start the following. Series converge or diverge. Okay, so let's start with 1. Look at this series, sum n equals, let's say, 1 to infinity of 1 over n cubed plus 5. Okay, so this series is not telescoping, it's not geometric, it's not the harmonic series, it's not a P series. Could I do the integral test? Maybe I could do the integral test. Okay, but let's do the comparison test here. Okay, even if we wanted to do the integral test, I mean, this integral 1 over x3 plus 5, I don't think it's an easy integral to do. Okay, so the integral test, forget it. It's possible, right? You could still decompose, but okay. First of all, what do you think? Is it going to converge or diverge? What's your intuition?
It's going to converge.
How do you know?
Well, it's 1 over something, so it's always going to like start getting smaller and smaller.
Yeah, but even 1 over n gets smaller and smaller, and it diverges.
I think it's because of the power.
What about it?
It's like bigger than when P is bigger than something.
Okay, that's very nice. Okay, so it's yeah, but it's still not a P series. If it was 1 over n3, I agree with you. But that's 1 over n3 plus 5. This 5 here is really bothering me. 1 over n3, I agree with you, it converges. 100%, it's a P series, P is bigger than 3. P is bigger than 1, sorry. But how do I do this? Okay, you're very close. You had a very good idea there. Okay, so look at what I'm going to do. I'm going to say 1, so I'm suspecting that it converges. So I need to find a bigger one, right? A bigger function, a bigger series that converges. Well, you know what? 1 over n3 plus 5 is definitely smaller than 1 over n3. That's for sure. This is true. Any complaints about this? Anybody don't agree with this?
So can you explain that?
This here?
Yeah.
Okay.
Yes.
So since the denominator here is bigger than the denominator there, right? Because I'm adding 5 to the denominator. So if I'm dividing by something bigger here. That's why it's smaller. This is smaller,
Okay, thank you.
right? Let me just so you can see my hands. Okay, so you understand? So if I'm dividing by something bigger, I'm getting something smaller, right? 1 over 20 is definitely smaller than 1 over 15.
Yeah, I understand. Thank you.
Okay, so now what did I just show? That 1 over n3 plus 5 is smaller than 1 over n3. So let's see. So 1 over n3 plus 5 is smaller than 1 over n3. Let's see if 1 over n3 converges. If this series 1 over n3 converges, then for sure the series an 1 over n3 plus 5 would converge by the comparison test. Okay, so 1 over n3 plus 5 is less than or equal to 1 over n3, and the series 1 over n cubed converges. This we know. How do we know?
Because
So,
the
yeah.
power is bigger.
Okay, so exactly. Okay, so you have to specify this on the test. Okay, when you're going to do the comparison test, you compare the two. This 1 over n3. You're stating that this converges. You have to tell me the test that you used here. So this I know it's a p series, and of course p is greater than 1. That's why it converges. Okay, so since 1 over n3 plus 5 is less than or equal to 1 over n3, and 1 over n3 the series converges, then the series an, so then the series n equals 1 to infinity of 1 over n cubed plus 5 also converges. By which test? I have to write the test by the comparison test. Example 2. Sum. Let's do n equals 2 until infinity. Let's do n plus 5 divided by n squared minus 3. Okay, so again, I'm looking at this and I'm going to ask myself, which test can I use? Okay, so obviously now I'm giving you the problem in the context of the comparison test, but on the exam or on the quiz, you will not know which test to use. Okay, so you have to go through all the process in your head, sort of flow chart, which I'm going to send you. I'm going to send you a flow chart that tells you which test to use in which order. But you would ask yourself, is it a telescoping? No. Is it a geometric? No. Could I use a divergence test? Try, do the limit of this, see if it's not 0. No, it gives you 0. The limit of the term gives you 0, so the divergence test fails. Could I use the integral test? Maybe you could integrate this function. It's complicated. Is it a p series? No. Is it an harmonic series? No. So let's go with the comparison test. Okay. What series am I going to compare this to? First of all, do you think convergence or divergence?
Diverges.
Okay, very good. Why?
Because you got an n on the top and on the bottom, so it's gonna both are gonna be in Chris cube.
No, that's not the reason. Okay, because if instead of being a 2 here, it was a 3, it would be converging. Okay, so the idea, and I'm going to show you how to look at it, okay, that n plus 5, really n goes to infinity, okay, just so I can see my fingers. So n goes to infinity, so the 5 is pretty negligible compared to the n. Okay, so I could sort of disregard the 5 in my head. Same as the bottom. N2 goes to infinity, and 3 is nothing compared to infinity, it's negligible. Okay, so I could disregard this 3 as well. So it's like if the overall behavior of the series is like n over n2. So just hide, I don't know if I can reach, but hide, right? Hide this. Okay, and n over 3 hide, 5 over 3 hide. You're left with n over, right? N over n2, which is like 1 over n. So this, I'm going to write this down. This series, so I'm going to write behaves. Okay, that's a really weird word for math. But behaves like 1 over n, like this series. Okay. It sort of has the same behavior because it's like the same order, right? N power 1, n power 2, n over n power 2 is like 1 over n. Okay, if that's why, if the bottom was n3 minus 3, then it would behave like n over n3, which is 1 over n2, which is a different story, which obviously converges because it's a p-series. Okay, so this behaves like this series, which of course diverges. True? Because it's the harmonic series. So let's try to compare this to this. If I could show that this term is bigger than 1 over n, I'm good, because I just showed that it's bigger than a diverging series. Okay, am I going too fast for anyone? Okay, so let's write n plus 5 over n2 minus 3. So I just want to show that it's bigger than this. Well, one second. This is definitely bigger than n over n2 minus 3, right? This is bigger because the numerator is bigger here. So it's bigger than that. Okay, and if I get rid of the minus 3 on the bottom, which is bigger?
The n over n power 2 minus 3.
Very good. This one's bigger because the denominator is bigger here, right? The denominator is smaller here. So if I divide by something bigger, smaller, I'm going to get something bigger. Okay? Okay, it's a bit confusing. You have to be careful here. Okay? And n over n2 is exactly 1 over n. So I just showed that n plus 5 over n2 minus 3 is definitely bigger than 1 over n. Okay, so this is the challenging part, to set up your inequalities like this. Anybody would like me to repeat this?
Sure, please, can you repeat?
Yeah, for sure. Okay, so again, the series n plus 5 over n2 minus 3, the overall behavior of this series is n over n2. Forget the constants. The constants are very negligible compared to n, which is infinity. So if I look at this overall, just with like my feeling about this, it's like n over n2, and n over n2 is 1 over n. Okay, so this series behaves about like this one. Okay, is this okay so far?
Yeah.
Okay, so this is the series that I'm going to compare it to. Okay, so it behaves like this one, so I'm suspecting that it's going to diverge as well, because this one diverges. Okay, so now that's the first step, is try to get a feel of whether it converges or diverges, and this is, for me, it's pretty clear that it's going to diverge. Okay, it won't always be as clear. Okay, so the only thing I know now is if I could prove that this term is bigger than this one. If it is bigger than a diverging series, then I'm done. This is divergent as well. Okay, So, and then that's the comparison test. So n plus 5 over n2 minus 3 is definitely bigger than n over n2 minus 3, definitely. Do you agree with this inequality here, the first one?
Yes, sir.
Okay, you sure, right? Okay.
Yeah.
Then, okay, and here, the second inequality, right? The denominator here is bigger, right? And 2 is bigger than n2 minus 3, right? If you minus 3, you get something smaller. So n2 is bigger than 3, therefore, I'm dividing n here by something bigger than here, so that's smaller.
So I don't get why we're comparing it with n over n square minus 3. Why not just n plus 5 over n square minus 3 and n over n squared?
Oh, why?
Yeah, why that one?
Oh, because I'm doing it step by step.
Okay.
You're okay with saying that this is smaller than this directly? You understand why? You're good?
Yeah.
Okay, good for you. I just did the extra step.
Okay.
Okay, if that was your question, that's okay. So n over n2, and that's 1 over n, okay?
But sir,
Yeah,
if we do this directly, like n plus 5 over n to the power of 2 minus 3 is bigger or is bigger than 1 over n.
okay. This is bigger than this?
Yeah,
You have to show me why.
okay.
Yeah, I want to be convinced here,
Okay.
okay?
Thank you.
Okay, and this series, of course, n equals 1 to infinity, 1 over n, diverges. Why does it diverge? Why is this one diverging?
Because when we divide like 1 over n, it gets smaller.
Because it gets what? No, why is this series divergent?
It's because of the P series.
Okay, but there was a name for this series.
The harmonic series?
Yeah, it's a harmonic series. Okay, this you have to know by now. If you don't right away recognize that this is a harmonic series and it diverges, that means you're a bit behind. And you're going to start struggling because we're going to use this a lot. Okay, don't let it accumulate. Finish the class, review what we did. Take time to review or else it doesn't stick. Okay, so this is a harmonic series. You have to know this because this is just going to be a tool to show it's divergent. If you don't even know the tool that you're going to use, then you will never show that this is divergent. It's impossible. Okay, so
Sure.
yes.
So we're essentially going to be taking everything you give us, and we're going to be ignoring the constants, and then we're just going to be simplifying n a little bit to show if it's converging or diverging.
In the case of a most of the time, that's what's going to happen. Yeah.
Okay.
Ignoring, no, it's just I'm not ignoring it, but I am like making it irrelevant a bit just to see the overall behavior of this series. That's all. Just to get an idea whether it's going to converge or diverge. Okay, so I look at this personally. I look at this right away. I say, well, of course it diverges right away. N over n2 is like 1 over n. 1 over n is the harmonic series, diverges, this diverges. That's it. That's what's going on in my head. It takes about 0.0002 seconds. Okay, but of course, I have to know that the 1 over n diverges, and because it's the harmonic series. If you don't know this, you're not going to go far. Okay, this you should know by now. Okay, we did this a few classes ago. That's it. It should be in your head. You can't, there's no hesitation here. Okay, so since n plus 5 over n2 minus 3 is greater than 1 over n, and 1 over n diverges, then, right, that's my second part of the comparison test, then the series n equals 2. So I could start at 2 here. 2 to infinity of n plus 5 over n2 minus 3 diverges. What's the reason? Why does it diverge? I need a justification here.
Comparison test.
Very good, thank you. Comparison test. Example 3. Let's do this. Series n equals let's say 3 to infinity of n squared plus 1 over the square root of n5 minus 7. So what do you think? Is it going to converge or diverge?
Diverge.
Diverge, very good. It's going to diverge. So let's compare it. What are we going to compare it to?
Something smaller than it.
Exactly. So you have to find something smaller than this that diverges. So this series seems to behave like what? Well, if you take out the 1, if you take out the minus 7, you get this one. And 2 over the square root of n5. Okay? Which is, if you simplify this, it becomes n2 over n to the n over 2, to the 5 over 2, which is 2.5. So 2 minus 2.5 is 1/2. So it's 1 over n to the half. So this is what I'm going to compare it to. And which diverges, right? Okay, so let's compare it. So let's go n2 plus 1 over square root of n5 minus 7. So I'm suspecting that it's going to diverge, so I want to find something smaller. I want to show that this is bigger than 1 over root n. So this is definitely bigger than n2. Again, so I'm doing n5 minus 7, and this is definitely bigger than, if I take out the minus 7 from the bottom, and that is 1 over root 5, 1 over root n. Okay, so I just showed that the term an, right? This is your an, and now this is your bn. Okay, so an is definitely bigger than or equal to bn, and the series bn diverges. How do you know that it diverges?
P series.
Good. P series And of course, P is less than 1. So we know that it diverges. Therefore, then my series, which is bigger than this one, diverges as well. Okay, by the comparison test. Limit comparison test. Okay, so it's very similar. Here it goes, two situations here. If limit n approaches infinity of an divided by bn is smaller than infinity. Okay, so it doesn't give me infinity, it gives you a natural number, whatever the number is. And the series bn converges, then the series an converges also. This is the first part of the test. Okay, so again, you will have to come up with a series the same way we did with the comparison test. We find the bn, but this time instead of trying to compare an bigger than bn, you will do an over bn. You will divide them and find the limit as n approaches infinity. Okay, if that limit gives you something that is less than infinity, so it gives you a number, then an converges as well, right? Provided that bn converges. And the other way, if limit as n approaches infinity, an over bn is a number that's not 0, okay, so it's bigger than 0, and the series bn diverges, then the series an diverges as well. Let me give you an example. So the series, let's say n equals 1 to infinity of, let's say, n2 minus 1 divided by n4, so n2, sorry, plus 1 over n4. So let's start it, sorry, I'm going to start it at 2 and 4 minus 3. Okay, so what do you think? Do you think that this series will converge or diverge? Just like before. Converge or diverge?
Converge.
Converge, right? It behaves like what?
A P series.
Which one?
1 over n power 2.
Okay, so this behaves like 1 over n2. So I'm pretty sure this is going to converge. Okay, so if I wanted to use the comparison test, I have to show that this term is less than 1 over n2. But you can't. It doesn't work. This is not smaller than 1 over n2. Okay, so although I know that this behaves like 1 over, and I know that it's going to converge, I cannot use a comparison test because of those technicalities. Not really small. It's very close, but it's not smaller than 1 over n2. So I have to use the limit comparison test here. Okay, so we write again. We write this. The series behaves like the convergent P-series, this one. Okay, this we know. I recognize this right away. But this term, n2 plus 1 over n4 minus 3 is okay. It's not true, right? The numerator is bigger here. The denominator is smaller here. This is bigger than this. Okay. We can't use the comparison test here. Okay, so let's use the limit comparison test. So instead of comparing them like this, let's divide them and do the limit. So limit n approaches infinity of an over bn. So n2 plus 1 over n4 minus 3 over bn, which is 1 over n2. Okay, so this is an over bn. Okay, let's evaluate this limit. I know that bn is convergent. This we know. So I just hope if this limit gives me something that's less than infinity, I'm good. Okay, you understand? That's what I need now. If it's less than infinity, I'm done. Because we know that bn converges. So that's limit n approaches infinity.
Sorry.
Yeah.
When you wrote the bounds, the second one says an over bn is greater than 0. And then the first one says an over bn is less than infinity.
Yeah.
Okay. Because I think, like, doesn't that give like a region where they're both? Where it could be greater than 0, but less than infinity?
Yeah, but in this case here, in the second case, it could be infinity. And the first case, it could be 0. As long as this is not infinity, and as long as this is not 0, I'm okay.
Okay.
Okay. Okay, so now I'm dividing a fraction by a fraction. So it's n2 plus 1 over n4 minus 3 times, and then you flip n2 over 1. That's equal to the limit as n approaches infinity of, so n4 plus n2 over n4 minus 3. And this gives me infinity over infinity. How do we find this limit?
L'Hopital rule.
You could do L'Hopital's rule or any technique you want. Let's do L'Hopital's rule. Limit n approaches infinity. So on top I have 4n cubed plus 2n, and on the bottom I have 4n cubed. Okay, I still have infinity over infinity, but now I could separate it into 2. Limit n approaches infinity. So the first is 1, right? 4n3 over 4n3 is 1, plus 2n over 4n3 is 1 over 2n squared. And if you plug in infinity here, you get 0 plus 1, you get 1.
Do we still evaluate it using the other way to evaluate limits of infinity?
Of course.
So like we would do like over n4?
Yeah, exactly. That's good.
Okay.
Okay, and this is definitely, of course, less than infinity. Okay, so this is less than infinity, and the series Bn, which is 1 over n2, converges. Again, by the p series with p greater than 1. Then my series sum n equals 2 to infinity of n2 plus 1 over n4 minus 3 converges by the limit comparison test.